So let's say you have a scale that you've used in a measurement and assessment of some participants, and you need to combine the different items on the scale into one composite variable, where the composite version of the variable represents the mean or average of all the scores on the items in the scale. And you can see that I've got some data here on the board. I've got 4 items with 10 data points each, and I've got a missing data point here. What I'll demonstrate in this video is how to manage transforming these variables into a new variable that's the mean score of the 4 items. I'll also show you what to do with the missing data. So in variable view in SPSS, what I did is I just created item 1, item 2, item 3, item 4. I just called them those items. If you wanted to continue, you could with item 5. Just type it out. Be aware that you cannot have a space in the item names. If I add the space in between the word item and the number 5, SPSS tells me I've done an illegal character. I don't want to get in trouble from the SPSS police, so I'm not going to do that. But I don't actually have 5 items, I only have 4. So highlighting this row in variable view, I can just hit the delete key. Well, I guess I have to be in data view. So in data view, I highlight the column. You see what happens is that when you go back and forth between data view and variable view, you go from rows in variable view to columns in data view. And of course, in data view, that's where you would input the numbers, unless you've imported them from Excel or some other database like that. All right, so in variable view, what I want to do first is I want to give these values a label, and you can see that the scores range from 1 to about 6 or 7. The highest one is 7. So let's imagine that this is a 7-point scale from strongly disagree to strongly agree. I'm not going to type in all the values, but I want to type in the extreme values, the 1 and 7. So the way that I do this is you just highlight one of these boxes here under values, one of these fields, and when you do that, you'll see that this little blue button becomes visible. Click that blue button. In the top field where it says value, type in the number that corresponds to the data point that you're trying to describe the value for, and the label. Let's say 1 is strongly disagree and 7 is strongly agree. So I type it in here. In this area, it is totally fine to have spaces in between the words. So strongly disagree. The reason why we want to put this in here is because I want to be able to see it in my SPSS output. And then 7 equals strongly agree. Now, normally I would put in all the intervening values as well, like disagree, slightly disagree, neutral, slightly agree, and agree for the values in between 1 and 7, but I don't want to do that. You get the idea. You can type in all those values on your own. So I click OK, and now you can see that I've got this set up here. I've got this system of value labels set up. I can copy that and paste it into the rest of the fields. So that's kind of nice. It saves some time. By the way, while I'm in here in the section looking at the variable view, if you run into some problems with data analysis, it's possible it could be because SPSS has this over here set on nominal data, when in fact what you're working with is scale data. So I'm going to change these to scale. Now the missing data point, you can see that I've got this missing data point here. And for what I'm going to do, it's not actually going to matter, but there are some instances where it would matter. And you don't want that to throw off your count. So under missing, and this is just a good practice for data management purposes. For missing, I'm going to do the same thing here. I click one of these fields. The little blue square becomes visible. Click that. And under discrete missing values, I'll put something that's not going to happen in real life, like the value of 99. 99 is better than 9 because, well, it also helps if I type the right number. It's easier for the eye to see if you have a big data set with hundreds of participants and dozens of variables. Your eye will catch that easier than it will the value of 9 in case you needed to find it. And so now SPSS will recognize the value of 99 as a missing data point, although it's not going to do it yet because I haven't defined the missing data point for the second variable, which is item 2. So I need to do the same thing of copying and pasting the missing data value of 99. So now whenever SPSS sees the number of 99 for any of these 4 variables, it's going to recognize that it should not use that number in any computations. Even if I didn't have it, let me delete that. Even if I didn't have it, if I went to analyze descriptives and frequencies to get the frequency count, you can see I've already done it. What you do is you take item 2, which is the one with a missing data point. I just want to show what happens when I don't have the missing data number operating and when I do. And you can see down here, it's going to recognize that I have a missing data, but it says system missing, and there's one frequency of that happening. Okay, so far so good. Let's see what happens though when I use the value of 99 and do the same thing with my frequency count. And run it again. I don't have to change anything here. Now it recognizes the value of 99 and it's going to treat it a little bit differently. Also, when I run analyses, it's going to treat it a little bit differently with that missing data point identified. So that's generally a good data practice to use whenever you're using scale data. Okay, the next thing I want to demonstrate is combining these 4 items together into one cumulative item or composite score item. Well, I guess it's no longer an item, it would be a scale. So I'm going to create this new value that I call scale mean. And the way to do that is go into transform, compute variable. Let me get rid of this stuff from a previous video. I'm going to call this scale mean. And that's going to be the name of my new variable that goes up here in the data view. Now to do this, what we need to do is we need to access the function group over here, and we scroll down to statistical function group. Highlight this one for mean and pull that up. Let me reset that to demonstrate again. I'm going to call my new variable scale mean. It's going to be the arithmetic mean of all 4 of the items that are on the board. I go to my function group over here on the right hand side of this pop-up and find the statistical function group, bring that up. Highlight the mean first and then bring that up. So you see it's a 2-step process. Go to the function group, get statistical, and then highlight mean and pull that up. Now it says mean of what? Within this pop-up you have all the different arithmetic functions, the not equal to sign, the greater and less than sign, the equal to, plus and minus, and asterisk is for multiplication. So what we want to do is we want to replace these question marks with the scale items. I take my cursor, put it on scale item number 1, bring that over, and you can see that the question mark has now disappeared. I'm going to highlight that second question mark and bring the second item over. Now it doesn't give me any more question marks, so what do? You have to just add a comma and then highlight the third item, bring that over, add another comma, highlight the fourth item, bring it over. And this is going to give me a new variable that's called scale mean. And you can see the values here are the means of these 4 items. Now if I had not used 99, it would have actually given me the same thing if I used this particular function. But let me show you a way that people sometimes do this that is wrong, and it'll give you the wrong answer. So if I get rid of 99 and I run the whole thing again, let me get rid of, so the answer here was 3.33 for the mean for subject number 6. If I get rid of that, go back to transform compute variable, everything is set up the same way, I'm going to run it again. You see that the number hasn't changed. So the fact that I had designated 999, or rather just 99, as a missing data point here didn't change anything because of the way that I transform my variable. But there is another way to do this, which is arguably the wrong way. Let me call this scale mean 2. Instead of using the statistical function group, I'm going to say, let's see, parentheses right here, item 1. This is sort of the old way of doing things, and it'll give you the wrong answer. So I'm taking my 4 items, adding them together using the plus sign and parentheses. And the reason why I have parentheses here is because I'm going to add this function at the end to divide by 4. And I have more than 4. Well, I have 4 items, but for participant number 6, there are only 3 observations. So using this approach is going to give me the wrong answer, and we can compare that side by side. So now it's actually not even going to count that person. But we might want to count that person. So that's, I guess, the issue between using the remaining data points or listwise deletion for that person with the missing data. So I would prefer to be able to use the participant's data that he or she provided information on. And I guess it's a judgment call. It depends on how many data points that person did answer. If the person answered most of the data points, then it might be in the researcher's judgment to use the mean of the ones that they did answer. But if the person answered only 1 or 2 out of, let's say, a dozen items, you would not want to use that person's data. So there's a judgment call that needs to be made there at some point. But you've seen 2 approaches now to calculating the mean score, and they will give you different results depending on whether you have missing data identified. Now, what happens if I do the same thing with the 99 here? Will it give me the answer for subject number 6? I'm going to delete that and run it again the way that I did here before, and you can see that it's still not counting that person even though it identified that missing data point as a 99. So there are costs and benefits to each way of doing it, and to some extent it's going to be subjective depending on your decision as to whether or not that participant has provided sufficient data for them to provide useful information on the scale. On some standardized scales, like the BASC, you'll have explicit directions that tell you that if there are 2 or more omissions of the data for a subscale, you can't use it. So it depends on the instructions for the scale if there is information about omissions, and if not, then it's the researcher's judgment call as to whether or not enough viable information has been provided. All right, well, thanks very much for watching, and I'll see you next time.